Howdy folks, I want to make a quick video doing a MyMathLab problem. I'll put the number of the MyMathLab problem in the name of the video. And we're asked to find the absolute extremum for the function f on this interval here. So remember what our steps are for doing this problem. Step 1 is to find the critical numbers on the interior of that interval. And then step 2 is to evaluate f at the critical numbers and also at the endpoints. And then step 3 will be to answer the question. So the first thing we need to do for this function is we need to go find the critical numbers. So let's do that. So our function here, f of x, is 3 cosine squared of x. And if we go to take the derivative of this, the derivative of this function is 6 cosine x to the first power, and then we multiply that by the derivative of the cosine of x. And that gives us 6 cosine of x minus 6 cosine of x sine of x. So notice that f prime is defined everywhere on that interior. So we're not going to get any critical numbers from f prime being undefined. Let's solve f prime of x is equal to 0 on the interval 0 to pi. So that happens when minus 6 cosine of x sine of x is equal to 0, which happens when either minus 6 equals 0, well that never happens. It happens when the cosine of x equals 0 or when the sine of x equals 0. Well, the cosine of x is 0 many places, but on the interval from 0 to pi, the cosine of x is only 0 at x equals pi over 2. The sine of x is also 0 many places, but on the open interval, careful, I'm talking about the open interval there, the sine of x is never 0, so there's no solutions to that. And so my only critical number is pi over 2. Folks, some of you might think that x equals 0 and x equals pi should be critical numbers. And the reason why you would give for that is that if you plugged f prime of 0, you would get out 0, and if you took f prime of pi, you would get out 0. So those are places where the first derivative is 0. But those are on the endpoints of the domain. Remember that our function, the domain we were restricted to, is 0 to pi. Those two values are on the endpoints of the domain, and we cannot include them when we consider our critical numbers. So it is true that our only critical number for this is pi over 2. Now, never fear, we're still going to take into account those two values because they are endpoints, and in just a moment, we'll be evaluating our function at those endpoints. So now we're ready to go ahead and evaluate. Let's go ahead and do step 2 now. So step 1. Step 2, let's go ahead and evaluate the critical number. So we're going to take, for our critical number, we're going to evaluate f of pi over 2. And for our endpoints, we're going to evaluate f of 0 and f of pi. So if I plug pi over 2 into where? Careful here, folks. Into the original function. We want to know how high, what is the height of the function at that particular x value. So we're going to plug in pi over 2 into the original function there. So don't make the mistake of plugging that into the derivative, because we want to know what is the y value when x is pi over 2. That should be a pi over 2. And so that gives us 3 times the cosine of, or 3 times 0 squared, which equals 0. And if we plug in 0 into this function, that's going to be 3 times the cosine squared of 0, and that is equal to 3. And if we plug in pi, that's going to be 3 times the cosine squared pi, which is 3 times the cosine of 3 times minus 1 squared, which is also equal to 3. And so we see that this function has an absolute max of 3 at x equals 0 and x equals pi. It has an absolute min of x equals 0, or excuse me, of a y equals 0, and that occurs at the x value of pi over 2. So there's our answer. As far as my math lab's concerned, we could enter that in. So we've got, it looks to be that choice B is the option, and we've got an absolute minimum, or maximum, of 3 at x equals 0 and at x equals pi. And we have an absolute minimum of 0, and that occurred at x equals pi over 2. Folks, what's important to keep in mind with this video is that the reason why we were checking pi over 2 into the original function is very different than the reason why we're checking 0 and pi in the original function. Pi over 2 was a critical number, and 0 and pi were the endpoints. And you must remember to check both when you go looking for the absolute extremum.